If you're doing any kind of coding, you need to know how to use Git to store your code. And although Git has a lot of powerful features, in normal day-to-day use, you're really only going to use a few simple concepts. Give me a few minutes and I'll show you how you can use Git locally with your code and how you can store your code in GitHub, the most popular online Git platform. I'm going to assume you already have Git installed locally. If you're running on Mac or Linux, it's probably already installed, and if not, it should be very easy to install it using the package manager. If you're on Windows, I have a separate video that steps you through the process of installing your Windows dev environment, including Git, so if you need help with that, check out the link up here. Okay, so we're gonna start from scratch and build your Git repo locally from nothing. So right now, the first thing we're going to do is create our directory and change into that directory, and that's going to be our empty repository. And then before we actually run any Git commands, I want to have you configure a property that'll allow you to make sure you're running the exact same commands I do as we go along. Type this command in and make sure that your default branch is called main. So that command is git config -- global init.defaultBranch main. You can copy and paste that from the description as well, but this will make sure that we're all running the same branches here. So now that we have that configuration set, we're going to actually initialize the repository. And to do that, you just type in git space init. And instantly, you now have a repository. If you type in git status, you'll see that you're on a particular branch, you have no commits, and there's no files in your branch to start working on yet. So we're going to fix that. So let's go ahead and create a file. I'm going to create a README file with just a quick line of text in there. And then once that's saved, if we type in git status, you'll see that now it shows that file is in your repository, but not part of the version control. So if you actually want to add it to the repository, we have to add it and then commit it. So you first add it, and if you do another git status, you'll see that it's ready to be committed. So adding it doesn't actually do anything yet. It's just ready to be committed. When you actually commit the file, then it becomes part of your repository and part of the version history for your code. So let's go ahead and commit that. And you always have to provide a message when you commit that just simply says, what's the summary of the reason you're committing this change in. And now what you'll see is when you do a git status, it says your branch is clean again. And clean just means that there are no changes from the last time you committed. And you can see what you have committed as far as your version history by typing in git log. And you can see you have one commit right now, and that is the first commit that you made with the first file. So I mentioned branches already, and branches allow you to work on code independently from the main source code that you have. You can have as many branches as you want to, but you always have to have at least one once you have code start being checked in. In this case, your main branch, which is named main, is the primary branch. It's going to hold everything that gets merged in. So if you type in git branch, you can see what branches you have. In this case, you just have the one, and the star next to it means you're currently on it. So let's go ahead and create a new branch that we're going to make changes to. So since we're on main and we typed in git branch JavaScript, we created a new branch called JavaScript it's actually the exact same point in time as where we currently are in main. So it has the README file, and so far that's it. If you type in git branch again, you'll see that we now have a new branch, but we're not on that branch. We're still on main. If you actually want to use the branch, you have to type in git checkout and the name of the branch. So now when we type in git branch, you'll see that we're actually on the JavaScript branch. At this point, the two branches are identical because no changes have been made yet. So let's go ahead and make a change inside this JavaScript branch. So I'm going to go ahead and make a new JavaScript file. It's going to do a hello world, super simple. Save that. So now we'll see that again, we have a file that's new to the system, and git status will show us that. So now we're going to do the same thing. We're going to do a git add and we're going to do a git commit. So it's now added to the JavaScript branch. So now we do a git log and we see there are now two commits. The most recent one adding the main.js file. So then you might be wondering, what about the main branch? Does the file show up there? Well, let's go check it out. To do that, we just switch back to the main branch. So we switch back by checking out. Once we're on the branch, if we do a quick ls, we see that the JavaScript file is not even there. And if we do a git log, we only have the one commit. And that is because the other commit is on the other branch. So the question is, how do we get those changes from the JavaScript branch into the main branch? And that is with the next concept, which is called merging. So you use git merge to take the commits that are different in one branch and merge them over into another branch. So in our case, we want to merge into main, and we're currently on the main branch, which is what you need to do. You need to be on the branch you want to merge to, and then you tell it, where do you want to merge from? So we type in git merge JavaScript. And in this simple case, because there have been no changes in main since we've made changes in JavaScript, it's a nice, quick, clean merge, moving the commits from JavaScript branch over to the main branch. So if we do, again, git log, you're going to see now we actually have that log, and we do an ls, and we see that we have the main.js file. So congratulations, you just did your first merge. So now that you've done a whole bunch of steps in the command line, let's go ahead and bring up an IDE just to make things a little bit more visual so you can tell easier what's happening. Okay, so now we see we have the two different files that we've edited and created here in the repository. I have a command line so I can show you the different commands you can run. So let's see what happens when we make different changes in different files and how the merges can handle those. So let's go ahead and make a quick change to the README and make a quick change to the JavaScript file as well. So if we do a quick git status on this one, you can see that both of the files are changed. If we list out our branches, you'll see we still have the old JavaScript branch. You can also delete branches, and I recommend doing that as you merge things in, just to keep things clean. So we'll do a quick git branch, the -d, and then the branch name. And then now the branch is gone. So this time we're going to create two different branches and make a commit into each one so I can show you what happens when you try to merge in multiple things at once. So first we'll make a branch for the README file. So now we'll go ahead and add the commit that we made to the README to that branch. Then we're going to go back to main and make another branch off of main. And this time I'm going to show you a shortcut. You don't actually need to create the branch and then check out the branch. If you want to just do it all in one step, you can actually use checkout with the -b flag, B for branch, and that will create and switch to the branch. So now we've created two different branches, which each one has a different change made to the file. If you notice up at the top, right now the README doesn't have my change, whereas the main file does. In the main file, I changed this to hello application, and in the README, I add a little bit of text after this initial text. If I change back over to the README branch, you'll see that will switch. See, there you go. They both just switch now. So if we go back to main, they'll both be gone. So now what happens when you try to merge both of them in? Well, you have to merge them in one at a time, obviously. If two people were working on these separately, one person would end up checking it in before the other just by pure chance. And that second person would have to worry about the consequences of being the second person to merge in. And let me show you what that is. In this case, the changes are independent, which is nice. So let me show you what happens when we merge in the first one. So that was a quick and easy merge, just like the first time around. We made the change, we merged it in, and now the file is updated. The git log shows a nice clean history of the changes you made. So now what happens when we try to merge in the next one? As you can see, this time it asked me for another commit message, and that's because we actually have to add a new merge commit, which Git will handle for us automatically, that will merge these two together because the histories were different between the two branches. So we save the message, and then Git will automatically merge two together. Luckily, in this case, there were no conflicts between the files, and so everything was nice and clean again. But when we do the git log this time, we'll actually see two different messages for this merge. At the very top, we see the merge commit, and that was where that change was added to the commit history of the main branch. But we have to go down to the next commit to see where we actually made that change in the original branch. So let's delete those branches real fast. And now let me show you one last case of merging, this time where two people have made a change to the same part of the code. So first, we'll create a new branch and make a change to the code. Go ahead and commit and change that to the first branch. And then let's go ahead and do this again on a separate branch off of main. So check out main, create another branch, and then we're going to make another change, which we, again, add and commit. So now if you go back to main and we try to merge both of them in, you're going to see there's a problem with the second merge. So the first one goes in, no problem. But now that we do the second one, you'll see that there's a whole lot of stuff that just happened. Number one, the output of the command actually says that there's a merge conflict and that we need to fix it before we can continue. So now we need to figure out where those conflicts are. In the error message, it tells you which files were affected. If you look inside the files, you'll see what the conflicts look like. So it's showing us that our code in our current branch looks like this, and that it's been modified since the original branch has been cut for the conflict 2. And the branch that we're merging in has code that looks like this. So we need to figure out which of these two do we want, or do we want to have a combination of the two? In our case, we want a combination of the two. We want this first line here, and we also want this line here, but not this one. So we manually decide what we want here. This is the final version we want, If we do a git status, we see that both have been modified and that's still in a merge conflict status. So now we, just like before, we can git add, and now we can commit to finish up the merge. And that's it. It's a bit of a pain, but if you're working on a team with a lot of other people, it's inevitable that you're going to end up working on the same parts of the code and have a merge conflict. So it's just good to know about this because this is a situation you can run into on a day-to-day basis. So that's why I wanted to show it to you. Finally, in the IDE, let me show you, like, if you do make changes to files, your IDE probably has ways to tell inside of your IDE, what files have changed. In my case, they'd be blue here. It also, what lines have changed inside the files. You can click on, usually see like what has changed. You can do a diff to see what changed across the entire file if you have a lot of changes there. Just like I'm using git log in the command line, you can do show history in this IDE, and you can see all the different commits that were made to that file. And your IDE will probably allow you to make commits as well. So I did want to originally show you the command line just so you knew how it worked from the very basics, but using the IDE, you'll be able to map those directly to the command that's running under the hood, like the add and the commit and changing branches and all this other stuff. Anyway, the actual integration will vary from IDE to IDE, but I still wanted to show it to you. So far, everything I've shown you has been local on your computer. That's all well and good, but the real power of Git is that you can then upload these files to online repositories and get collaboration from other members on your team in a company, or like for open source code, you can work with people across the entire globe, or even just, if it's only your own projects, you at least have a backup of your code in the cloud that you can always go back and access. So let me show you how to do this with GitHub. So before we go to GitHub, we need one more thing to do locally, and that is to make sure you have an SSH key. So first, look to see if you actually have an SSH key. And to do that, you're just going to look in your home folder. There should be a .ssh folder, and there should be a .pub file in there. If so, then you already have a file. If not, you're going to type in the command ssh-keygen, and that will step you through the process of actually making a file that we can upload to GitHub. So once you have that generated, you're going to want to get the contents of that using the editor of your choice, or I'm just using cat, the Unix command line, to print it out to the command line. And we're going to be using that in the next step, which is making sure that your GitHub can be accessed from your command line. So go ahead and log into GitHub, and you're going to go to your profile, go to settings, and then click on SSH and GPG keys over here. Then you're going to open up the new SSH key dialog. You're going to paste in that entire text that we copied, give your key a name, and then go ahead and hit add. And if you go back to your keys, you should see them listed as one of your SSH keys. So this will be important in the next couple of steps. But now what we're going to do is we're going to create a new repository. So go back to your home by clicking the GitHub logo in the upper left here, and then click New next to repository. Give your repository a name, decide whether you want it to be public or not. You can decide what options you want to choose from the list, and then hit the Create Repository button. So if you were starting from scratch where you had no files yet, you would follow the instructions at the top half of this page. That would be these right here. However, we already have a repository, and we've added some commits and we have some files in there, so we want to follow the bottom half. The first line links your local repository to the GitHub repository. The second command just takes whatever branch you're currently in and renames it to main, which is what GitHub expects as its primary branch. And that last command is going to push your local branch and all its files up to GitHub. So if we copy all three, go back to our repository, make sure we're running on the main branch, then paste these commands in. Now we should be all set. And if you go back to GitHub and refresh the page, you'll see that our repository now shows the README we created earlier. It also has the main.js file that we created too. You can click into these and see what the contents are just by navigating. The UI in GitHub will allow you to do many of the things I showed you before, like adding new files, showing diffs, showing logs, viewing the contents of the files. So it's useful to click around and see what's available here. But a couple of things I want to show you that are useful to know specifically about GitHub are, number one, the Issues tab. The Issues tab is where you can track work related to your code. So you would have a list of bugs you need to work on, new features you want to create, anything at all that you want to have in here. For larger projects, it also ends up being a place for discussion about potential features or problems and figuring out if they need to be worked on. but this is a great place to be able to track work without going into outside programs. And then next you have pull requests. If you're working with multiple people on a project, this is where you can actually review other people's code before it gets merged into the main branch. Again, for larger projects, this is very critical because certain people will have the privileges, the rights to be able to allow those merges in, but they can allow anybody to submit a pull request for review. This way you can get a lot of these larger open source projects to get a lot of people working on them, even if each individual person only works a little bit on it. You still have that core team that acts as like a check and balance to make sure that any code that does make it into the project has been reviewed and vetted and gone through this pull request process. So you don't have to manually merge things into the command line if you wanted to just use this UI instead. So lastly, now that you've created your own repositories, let me quickly show you how you can use other repositories from other developers. So for instance, let's say we wanted to look at or even work on the React repository. So we can go find that on GitHub. And if we go into that repository, you'll see the big green button that will allow you to download the code yourself. Now there's different ways to download it. If you just use HTTPS, that's essentially a read-only version of it. If you go to the SSH version, that will give you read and write access to it. So let's copy that URL and then I'll show you how to use Git to get it onto your computer. So let's go to a new folder where we're going to create our React repository. So to clone the repository, we're going to type in git clone and the repository URL. By default, it's going to put the entire repository in a new folder named of the repository. So in this case, React. If you wanted something different, you can just put another argument after that was the name you wanted it to be. Like in this case, my React folder or something. But I'm going to stick with the regular React and then wait for it to download. So that's it. Once it's downloaded, now you can go into the folder and view the entire source code of React. Now, this is a direct link to the Facebook React repository on GitHub. You can also create your own copy of that repository inside of your own account in GitHub. And that's also very commonly used when you want to contribute to a project. So to do that, that's called forking a project. So you go back to the UI in GitHub, and instead of clicking on the code button, you're going to click on the fork button over here. And by clicking the create new fork button, we can then add this repository to our own personal namespace. One other thing to notice, since you're running a fork of another person's repository, you have another status bar here that tells you whether or not your particular version of the repository is up to date with the original place you synced it from. So if you wanted to, you could press this button here to actually sync your repository with the source repository. This way you get all the latest commits just flowing straight into your main repository. So anyway, it's useful to know that you can create your own copies of any repository that's public in GitHub, and you'll have it then listed under your own namespace. And at any time you want to, you can sync it up as well. So that's it. Those are the concepts you need to know in GitHub and you'll use on a regular basis. If you have any questions, let me know in the comments. And if you like this video, please subscribe to my channel. Thanks for watching, and I'll see you next time.